try an example. Let's see if we can find the velocity and acceleration vectors for P of t is cosine comma sine. And maybe draw a picture and figure out what the heck is going on. Okay, so that's P of t. Say that again. That was smart.
What?
Whoever said circle.
That was me.
Clearly a circle,
Yeah.
right? Okay, so what's the velocity vector for this thing? How do you get it?
Just derivative of both components.
Yeah, you really do d dt, right, of this thing. And then pretend this is scalar multiplication, right? So this is a little bit cheating, right? But we remember that these hard d's, right, they really go with scalars. So we'll just kind of look at that thing and we're going to think it's a scalar. We'll throw it into the bits. So we'll get a vector made of d dt cosine t, comma d dt sine t. And I'm probably beating the heck out of this, aren't I? Okay, so what do you get?
Negative sine t cosine t.
Okay, negative sine t, comma cosine t.
Yeah.
Okay. That's a vector, right?
Yeah.
What did I think velocity was going to be?
A vector.
Really?
Yeah, magnitude and direction.
Yeah. What do those mean? Right, there's two pieces of information here, right? There's a direction that this thing's pointing and how long it is.
Oh, like its magnitude, its length. Right?
Yeah, the magnitude's the length of the velocity vector. What the heck is that? What's velocity in loose terms?
Change in.
What's velocity in motorcycle terms? Where do you read the velocity on your motorcycle?
Speedometer?
Yeah, the speedometer, right?
I don't know why I call it speedometer.
So, what's the deal? Because that's not a place on my speedometer, right?
No.
What's the difference between a velocity and a speed?
Velocity has direction.
Velocity has a direction. Speed is just the,
Just the rate of change.
yeah, it's the kind of absolute rate of change. It's the magnitude of this vector. Does that make sense?
Oh.
So it would be like the second derivative? No, that would just be.
Yeah, it's not a second derivative. It's literally just, if you throw the location, right, the direction information from this away,
It's just meant.
how long is that vector? That's your speed. Does that make sense?
Yeah.
Okay. So, I got velocity. Where do I get acceleration?
The second derivative.
Okay, so you do
D squared t.
d squared
Oh yeah.
dt squared,
Yeah.
right? So this thing. And I won't beat you guys up with multiplying that in. What do you get?
Negative cosine t and sine. Negative sine t.
Okay. You guys want to see a picture?
Yeah.
Because, like, sure, this happened, right? Okay, so let's talk about, I got three colors. Let's do blacks or t is 0.
It's in the middle.
So when t is 0, what's your position?
1, 0, 0.
It's what?
1, 0.
It's 1 0.
1, 0. Okay, so here's your position. Oops, p of 0.
Oh, 0.
0, 1.
Yeah, it's 0.
Velocity is 0, 1. 0 over 1 up.
Velocity.
And what's your acceleration? Negative 1, 0. Yeah, let's see, so position and acceleration were just opposites of one another, right? What the heck's going on here?
Acceleration's going down.
It is.
If I look at it,
Okay, maybe let's do another one. Let's do t is, what if I wanted this one? What would I pick for my time? Pi over 4? Okay, what's v at pi over 4? So there's p at pi over 4. Oops, and I've lost some vector hats on these things.
It'd just be the other side.
Should be something like this. Okay, and then what's acceleration?
Keep going back down parallel
Yeah.
to the first one.
Back down parallel to the first one.
So probably should be.
Okay, so what's going on? Which way am I going around this thing? In my parameterization.
Clockwise.
Yeah, I'm going counterclockwise, right? So what's happening is I'm thinking about if you're going this way, right? What's your velocity vector?
tangent.
That's tangent to the circle, right?
Magnitude 1.
With a magnitude of 1. So I'm going around this thing at unit speed, right? Why is the acceleration vector pointed back in towards the middle? Back.
Along the circle.
Yeah, the acceleration's the change in the velocity, right? The velocity better be pulled horizontally a little bit at that beginning bit. Otherwise, I wouldn't stay in the circle. You guys see that? Okay, so what's the interpretation for the velocity vector? If you're, what's this thing called? A point?
Point.
Do you have one?
I don't actually have my back on me today.
Damn.
The one day it would be useful.
I know.
Trusted you with one thing.
Are you gonna swing the top?
You can always get a keychain off someone's lanyard.
I borrowed this. Never mind what's happening. Okay, so I need to go oops, the other way for you guys, right? So here's your position. What's the velocity vector represent?
The velocity.
If you let it go, it's the direction it would fly.
Yeah, if I let it go, right? If I stopped accelerating it around, if I stopped applying force to it, right? The velocity vector is the direction in which it's going to kind of continue to travel, right? You guys see that? So that velocity vector is the instantaneous direction this thing's going, and the length of that velocity vector is how fast it's going. You guys see that? A similar thing is true with the acceleration vector, right? The acceleration vector is telling you in which way is the velocity changing and how fast. Does that make sense? Questions, things? I was really hoping you'd have the point.